Hello, Algebra 1. This is video key for 7.6 homework, and that was factoring trinomials when our leading coefficient of a was equal to 1. So let's take a look at the 12 problems on this homework assignment, starting with the first 6, which were the diamond problems. Okay, so here are our first 3 diamond problems. Here's number 1. We have 12 and 7 were the 2 numbers given to us. So the whole point of this is we're trying to find 2 numbers when we multiply them together equal 12, when we add them together equals 7. So let's take a look at 12. Since this is the one that we have to find the multiples of, let's start by looking at all the factor pairs of 12. What can we multiply to get 12? Well, 1 and 12 or -1 and -12. Next we would have 2 and 6 or -2 and -6. And finally, 3 and 4, or -3 and -4. So these are all the possible combinations of 2 numbers we can multiply together to equal 12. Now we just look at each pair individually and see which ones, when we add them together, equal 7. Well, 1 plus 12 is 13, -1 plus -12 is -13, 2 plus 6 is 8, -2 plus -6 is -8, 3 plus 4 is 7, and we can stop. There's our winner. So we'll have 3 and 4 right there. Okay. Let's look at our second diamond problem, 48 and 16. So we define all of our factor pairs of 48. So 1 and 48, or -1 and -48. We also have 2 and 24, or -2 and -24. We would have 3 and, what would that be, 3 would go in there, 16. -3 and -16. We also have 4 and 12, or -4, -12. I believe, yeah, 6 goes in there as well. 6 and 8, or -6 and -8. There's all our factor pairs that can be multiplied together to equal 48. Let's just scan across these, see if there's any one of these that when we add them together, get us 16. That's 49, -49, that's 26, -26, 19, -19, 16. There it is right there, 4 and 12. So those will be the 2 numbers, we just found them, that when multiplied together equal 48, when added together equal 16. Finally, let's take a look at number 3. Number 3, we're looking for the numbers that multiply to give us 20. So let's start finding those factor pairs. We got 1 and 20, -1 and -20, 2 and 10, -2 and -10, 4 and 5, -4 and -5. There's all our possible combinations of numbers we can multiply together to get to 20. Let's just scan these and see what we get when we add them together. 21, -21, 12, -12, 9. That's what we're looking for. So the 2 numbers here would be 4 and 5. So there's our first 3 diamond problems. Now let's take a look at 4 through 6. Here are our next 3 diamond problems, number 4, 5, and 6. Let's take a look at number 4. We want to find 2 numbers when multiplied together give us 40, when added together give us 14. So let's break down the factor pairs of 40. We have 1 and 40, -1 and 40. We'll have 2 and 20, -2 and -20. 3 does not go in there, 4 does. 4 and 10, -4 and -10. We also have 5 and 8, and -5 and -8. Okay. So these are all of our factors of 40. So let's start looking together. Let's look across these, add them together. 41, that should be a -40 right there. 41, -41, 22, -22, 14, that's what we're looking for, so we can stop right there. Our numbers are 4 and 10. Okay, let's take a look at number 5, which is 81 and -18. So we're going to want to start looking at all the factor pairs of 81. So we have 1 and 81, we have -1 and -81. 2 does not go in 81. 3 does, however. It goes 27 times. So we'll have 3 and 27, or negative 3 and negative 27. 4 does not go, 5 does not go, 6 does not go, 7 does not go, 8 doesn't go, 9 does. We'll have 9, 9, and negative 9, negative 9. So scan across here, see what they add up to. 82, negative 82, 30, negative 30, 18, negative 18. Those are the two we're looking for. Numbers are negative 9, negative 9. So hopefully this shows you the importance of when you're looking at these factor pairs, look at positive and negative for this very reason. Okay, our answer was the negative factors of negative 9 and negative 9. Okay, let's look at our last diamond problem, which is number 6. We're looking for all the factor pairs of negative 18, and we're looking specifically for that pair that when we add them together equals negative 3. So we'll have 1 and negative 18, or negative 1 and 18. So we're multiplying for a negative. Remember, it's a positive and a negative. When multiplied together, going to give us that negative. So it's a positive 1 and a negative 18, or a negative 1 and a positive 18. We also have 2 and negative 9, or negative 2, positive 9. Finally, we'll have 3 and negative 6, or negative 3 and 6. Okay, let's add these together. Here we have negative 17. Here we have positive 17, negative 7, positive 7, negative 3. Here it is right here. So we're looking for 3 and negative 6. Those two numbers, when multiplied together, give you a negative 18. Added together, give you a negative 3. So there's a look at our diamond problems. Now let's see how we can use this skill in factoring trinomials. Okay, here is number 7. This is our first factoring a trinomial problem. Okay. So if you remember when we went over in the lesson what the standard form of a quadratic equation looks like, it's a to the x squared plus b to the x plus c. Now, it doesn't matter if your variable is an x or a k. What we're really interested in identifying with this standard equation are the coefficients. So in this case, what's the coefficient of k squared? That's going to be our a. Well, if it's not there, you just assume it's a 1. Okay. What's our coefficient of our k? That's going to be b. That's going to be negative 6. Okay, and then finally we have our constant number, c equals 8. So a, b, and c, those are the equivalent of the coefficients of our quadratic equation here. So a, b, and c, our coefficients are 1, negative 6, and 8. Where a equals 1, b equals negative 6, c equals 8. Now the diamond problem, we were working on problems 1 through 6. We can put c up here and b down here, because what we're looking for is two numbers that will multiply together equal this constant, or c. When added together, give us this coefficient here of negative 6. So we're going to replace this if we wanted to with 8 up top and negative 6 on the bottom. So let's look at our factor pairs for 8. We have 1 and 8, or negative 1 and negative 8. Negative 2 and negative 4, or positive 2 and positive 4. Those are the numbers that we multiply together can give us 8. Well, let's add them together and see what gets us negative 6. That gets us 9, that gets us negative 9, this gives us negative 6 right here. So those are two numbers, negative 2 and negative 4. Well, great. Now that I've found these numbers, what do I do with them? Okay. A factored form of a quadratic equation is a set of two parentheses. We're going to have our variable here. So we're going to have k here and k here. Now what we're looking for to finish these off are the numbers here. Negative 2, negative 4. There's our answer, k minus 2 and k minus 4. Okay, if you were to FOIL this back out, this would get you right back where you started. So factoring is like foiling in reverse, but this is our answer here, k minus 2 and k minus 4. Okay, here's number 8, n squared minus 8n minus 20. So again, let's identify what our a is, what our b is, and what our c is. Our a is 1. Our b is the coefficient here in the middle term, it's negative 8. And c is our constant, which is going to be negative 20. So remember, we could just have c at the top, b at the bottom if we want to turn this into a diamond problem. So we're looking for two numbers that multiply to negative 20 that add together to give us negative 8. So let's start finding the factor pairs for negative 20. We have -1 and +20, or +1 and a -20. We'll have a -2 and a +10, or a 2 and a -10. We'll have a +4 and a -5, or a -5 and a +4. There's all our possible pairs that we can multiply together to get to -20. Let's see what they add up to. -21, I'm sorry, 19, -19, 8, -8, that's what we're looking for, isn't it? So our two numbers are 2 and -10. So remember, our factored form is going to be a set of parentheses. We're going to have the n leading the way in the front of both parentheses, and we just put our numbers in here, +2 and a -10. So there's our answer, n plus 2, n minus 10. Here's number 9, m squared minus 2m minus 15. So let's identify our a, b, and c. A equals 1, b equals -2, and c is our constant, -15. So we're going to put our b and our c into our diamond problem. Our c goes up on top, -15, our b down there at the bottom, -2. All right, so let's look at all our factor pairs that when multiplied together give us -15. We'll have a +1 and -15, -1 and a +15. 2 doesn't go to 15, 3 does. 3 and -5, or -3 and 5, and that's it. That's all we can get to -15. So let's add them up. This is -14, +14, -2, that's what we're looking for. So we have a +3 and a -5. Now let's write our factored form, two sets of parentheses. Our variable is going to lead the way, and then we just substitute our numbers in, +3, -5. There's our answer, m plus 3, m minus 5. Let's take a look at number 10. Number 10, x squared minus 14x plus 48. So we're going to identify our a, b, and c. A is 1, b is -14, and c is 48. Let's put our c of 48 up top here, and b down below, b for below, -14. Okay, let's find our factor pairs of 48. We have 1 and 48, or -1 and -48. We have 2 and 24, or -2 and -24. We have 3 and 16, or -3 and -16. We'll have 4 and 12, or -4 and -12. Running out of room, so I'm going to put this over here. I have 6 and 8, or -6 and -8. And those are all the possible factor pairs, all the numbers we can multiply together and get to 48. So as we add them together, I can kind of see it already. When I wrote that over here, I saw that -6 and -8, when added together, are going to give us -14. So there's our two numbers, -6 and -8. So let's put our factored form down here. Our two parentheses, our variable of x is going to lead the way. And then we're just going to drop in our two numbers from our diamond. And our answer is x minus 6 and x minus 8. On to number 11. R squared plus 3r minus 10. Okay, so let's identify our a, b, and c. A equals 1, b equals 3, c equals -10. Okay, let's drop our b and our c into our diamond. C goes up top, b for below, b goes below. We need to find two numbers that would multiply together, give us -10, that when added together, give us 3. So let's look at all the factor pairs for -10. We have -1 and 10, or 1 and -10, 2 and -5, or -2 and 5, and that's it. Okay, so this added together gives us 9, -9, -3, +3. There's our two numbers, -2 and +5. Put our parentheses so we can write this in factored form. Our variable leads the way, r and r. Let's drop in our two numbers from our diamond, r minus 2, r plus 5. There is our answer for number 11. Number 12, our last problem on this homework assignment, x squared minus 15x plus 50. First thing, of course, we have to do, identify a, b, and c. A is 1, b is negative 15, and c equals 50. So we're going to drop our b and our c into our diamond. C is 50, b for below, so negative 15 goes below. And we're looking for two numbers we can multiply together to get 50. When added together, gives us negative 15. So let's find all the factor pairs of 50. We get 1 and 50, or negative 1 and negative 50. We get 2 and 25, or negative 2 and negative 25. We will get 5 and 10, or negative 5 and negative 10. So there we go. Let's add these together. 51, negative 51, 27, negative 27, 15, negative 15. That's what we're looking for right there. So minus 5 and minus 10 are the two numbers we want. So let's put the parentheses so we can rewrite this in factored form. Our variable leads the way. Then we drop in our two numbers from our diamond, negative 5 and negative 10. There's our answer, x minus 5, x minus 10. So hopefully this helped you understand the problems on this homework assignment. If not, please email me. Hope this helped.